Although we specialize in medical device test fixtures at Pipeline, every now and then we like to send our customers gifts. Check out the custom-made triple thread fidget spinner, made nowhere else other than us. So number one, you can spin it like a fidget spinner, but then it snaps into place due to magnets. Number two, you can twist it and it snaps due to magnets in the bottom. Gives you that satisfying snap that'll keep you snapping all day long when you're in your phone calls. Number three, due to the rounded designs in the bottom, if you spin it hard enough, it turns into a spinning top. Let's take a look at the CAD model and some of the work that was put into designing this. So here we have the assembly file, and please let me introduce myself. My name is Rafael Testay, and I'm a mechanical design engineer here at Pipeline Design and Engineering. I wanted to put a face to a name and a face to a voice, rather, so that you can know who I am and we can start building that personal relationship as you watch our videos. So the assembly file, here it is. It's mated, and it should function like it functions in person as it spins. But you may notice that some of the hardware is missing, like the magnet that goes in here. There's a magnet that goes under one of those, under one of those arms. There's a ball bearing that's also not here. So why is the ball bearing not here? Because we got the ball bearings off of Amazon, because it's cheaper to get those ball bearings instead of from other providers. And Amazon doesn't have a CAD file for those ball bearings. But as long as we have the measurements, it's totally okay. So that's why that space is missing. So let's take a look at how everything functions. We have a washer that was 3D printed. So let's start hiding some of these components. And we have the disc here, the ball bearing that goes through, the dowel pin that goes through. And let me take a look at this in the wireframe view so now you can see what's going on inside. See that dowel pin going through? And there's going to be a threaded insert here with a screw, and this is another magnet that's coming in contact with the dowel pin. And let's add some color to this or bring it back to normal. And there it is. See, there's a magnet inside that bottom part, and that's coming in contact with the dowel pin, and that's causing the magnet to stay. It gives you that satisfying feel that when you take out the base and you put it back on. Now, one of my favorite things is the design that I made for these shark fins. So when you spin the base, highlighted to the left, the fins will cause it to move in the upwards and downwards motion. And that's going to create that snapping sound that I showed in the video before. So this is the assembly file. Let me show you what I did before this to get to the assembly file. We do something called master part modeling, and it's just a part file. And all these sketches are here, and we build all the parts in one part file, and then we do save bodies. Now these SolidWorks files we'll be able to download for free in the description of the video. Give us feedback if you can download them successfully. And if you download them, please give it at least a thumbs up and subscribe to us, because we got more interesting content coming up. So I'm going to show you the 3 most interesting things about this CAD model that I thought at least the most interesting. So this washer is 3D printed. And the way that you have to make this washer in order for the Fidget Widget to spin and work is when you have a ball bearing, that washer, the top surface of the washer, can only interface with this ID of the ball bearing. If the top surface of the washer touches both the ID and the OD surfaces of the ball bearing is not going to be able to spin. And I figured this out by disassembling a fidget spinner. So it works appropriately, like I showed in the video. Feature number 2 that I want to show you is this text that you'll see here. designtheproduct.com text. That's our website. Feel free to check it out and contact us. But the text is a wraparound text. You probably already know how to do that, but there's a more interesting thing about this, is that we put 45-degree chamfer cutouts so that none of these engravings need support when they're 3D printed. So that gives it the correct finish. It doesn't give it a rough finish, and it saves material. So that's a nice little tip that you'll be able to see how we did that once you download the file here. Now I'm going to show you my favorite feature of the whole model. So we wanted to add weight at the end of the arms of a fidget spinner. So we decided to do something pretty creative, which I'm very excited to show you. So we did some nut cutouts, and then we got 2 nuts, and then we put them in the spaces that we cut out, and then we resume the printing job. So here's the cross-section view, so you can see there are cutouts that would fit a nut off the shelf. See the cutouts? An actual nut goes in there. We don't have the nut file here in the CAD model, so let me explain. So the first thing we did was the cutout for the nut, and then we went to the 3D printing settings, and we told it when it got to this layer, we told it to stop printing, just pause printing. And then we went physically to the printer, we opened the printer, and we placed one nut here, and we placed another nut here. Imagine it's all a flat surface until then. And then we clicked a button that said resume printing, and then it went back to printing layer by layer. Now what that did, it added weight at the end of the arms of the fidget spinner, and it locked the nut in place. And we thought that was pretty cool. That's a little bit of an example of how we pay attention to detail here at Pipeline. And most people won't even notice. They won't even know that there's a nut on the inside, but everyone that watched the video knows and could appreciate that. So if you like this video, please like, comment, subscribe, download the files in the description, and share this video with your friends. Until next time.
At Pipeline Design and Engineering, we design incredible test fixtures. Using a combination of precision machined and 3D printed components, we are able to balance cost and capability to deliver phenomenal value to our customers. Many of our fixtures incorporate some level of motion control and automation. In fact, we have created a suite of software tools in LabVIEW to control everything from motors to air cylinders based on the specific needs of our customers' applications. We can also provide turnkey system integration for your project, using a variety of inputs such as force and torque gauges to trigger key events in your automation process, and a custom PC-based UI for users to control this process. Some of our customers need fixtures that interact with legacy components for which no CAD data exists. Pipeline provides in-house 3D scanning and reverse engineering for these situations and can produce design intent CAD assemblies for even your most challenging projects. This CAD data can then be used as references for test fixtures or simply for manufacturing. Our mission is to create elegant solutions for passionate customers by being experts in the field of mechanical design and engineering, and we'd love to talk to you about your next project. Please contact us today at info@designtheproduct.com or by calling 480-241-4764.